All right, so we want to get started, I guess. Oh, we getting a whiteboard? No, we're not. If we need it, we've got one. So good morning, my name is Tim May, and I'm the coordinator of the AI Meetup, helping Matthew Rinzi out, who started the group. We have 3 short presentations today. I'm going to take everybody through a gentle introduction to using analytics in the marketing arena, which I've done a lot of over the years. I'm a retired CTO. I've also held positions of Chief Operating Officer and Chief Analytics Officer, so I've bounced around a lot of things. I've also had a couple of exits as CEO in small companies. So I've been an entrepreneur for many years, so one of the things I like to do is help people who are starting new enterprises or a new business effort inside a larger organization sort of hit the ground running, know what kinds of questions to ask, what kinds of ways, opportunities exist to leverage technology to improve their business outcomes, right? So please stop me anytime, ask a question, encourage that. We also have Thomas May is going to be presenting a talk on some of the algorithms used to sort of manage robotic navigations, which is a big deal these days, right? We're seeing a lot of that. And Peter Smith, who's here, is also going to give a brief talk on, what did you call it, Peter? Wizard of Oz with AI, I guess it was, right? There we go. So one of the things before we get into the presentation on marketing, I wanted you guys to go ahead and feel free to capture this code and link with me on LinkedIn, especially if any of you have something you'd like to talk about, or you'd like to, reach out to us and let us know the kinds of things that you have a particular interest in. So we're always looking for interesting subject matter, right? So if you have, hey, I really like to know about, you might not be the only one who has that question or that interest. So I'd like to, really make this a community process and get everybody involved. So feel free, absolutely free to reach out. So next. So this is going to be a very gentle introduction. I'm not going to get heavy into algorithms. I'm going to talk more about business process, focus, and kind of utility. And so what we're going to look at primarily is knowing your customer, because if you know your customer, you're much more likely to engage with that customer successfully to get a conversion, make some money, which we all want to do, right? We all want to get some money. Or as a customer, you might want to know what they're trying to keep track of on their end to make money off you, right? We should all think of ourselves as the product these days, so be very careful about that. So some of you have a technical background, and if you ever did technical writing, I'm sure you remember this, the ABCs of technical writing: accuracy, brevity, and clarity. Who's done a technical writing course and recognizes this? There you go, at least one. This was something that I have found extremely valuable in managing technical writing operations in companies over the years. Take it back to the simple, remind people the things that matter, right? So this acronym really helped with that. Let's look for the same thing, that bedrock focus in analytics on the for around marketing. And I use the term art. Is something actionable? Does it offer something that a customer can take action on? Is it relevant to them? And is it timely? Art. If you can always ask those 3 questions, there are others, but these are the key ones. In your marketing efforts, you usually end up, in my opinion, with a more effective campaign, a more effective engagement. So, yes, Thomas?
Do you mean like if you have a coupon, sending someone a coupon for a room isn't very useful if they're far away, and vice versa?
Oh, it's the opposite. If they're far away and traveling, they'll need a room. If they're local, they don't. But yeah, I'm going to actually get into that. So let's start with kinds of data we collect. I'm going to use a casino example. We're in Vegas, why not? In addition, I've worked with hundreds of casinos across the country over the years in marketing programs. We built automated marketing platform, and so we would integrate that with their loyalty programs and whatnot. So there's a long list of data points they collect, but let's talk about 4, I guess, here. The first is, how much money are they, on average, going to take from you every day as a player, right? That's the average daily win or average theoretical loss. They have a lot of different terms for it, but essentially it's how much money they want to make off a player. And on average, how much does a player sort of support the casino's bottom line? What games do they play? That's pretty good to know, right? If somebody's a poker player, then they're going to want to know about poker tournaments and they'll care about slot play tournaments. Location, where are they located? Are they local? Are they somebody can drive to the facility, or they have to fly from some place in the country? again, that can really affect the kinds of offers and engagement you have with that prospective player. And then their trip history, when they come, are they likely to stay a day, a couple days, a week, a weekend? These kinds of things are key. So one of the things I want to do here is now take these data metrics and drop them into the buckets that we just talked about earlier, which is, okay, let's talk about offers. So hotel rooms, parking, entry fees for a tournament, poker tournament, free slot play is a big one, of course, and off-time offers, like use the facilities when they're not usually used to maximize people's engagement. So connecting the dots. We're going to take a casino loyalty program example. We're going to take each of those pieces of data that we've talked about, and we're going to drop them into these buckets of actionable, relevant, and timely. So first one, ADW, that average win that they want to, money they want to take. Where do you think that would go? Who would like to take it? There you go. Okay. Next one, games. There you go. Next one, location. Absolutely. Next one.
3 for 3.
Yay. One more. Last bucket, right? So the idea is that you can actually get a better sense and communicate more effectively with your team, both the marketing side and the analytics, if you kind of break it down into these buckets. Next thing we want to do is create offers. Notice that these offers also fall in the same kinds of buckets. So hotel room that Thomas brought up, and parking. Those are relevant in different ways to location. Does a local need parking overnight, long term? Not as much. If they're an RVer, they definitely need a certain kind of parking support. Hotel rooms, if they're locals, they probably don't need a hotel room unless it's staycation, I guess. But if they're flying in, then a hotel room might be a really interesting offer for them. Relevancy, free slot play. If they don't play slots, right? Poker tournament, if they're a poker player. And then finally, I've got the timeliness. Entertainment events. If they are someone who comes all the time in a particular part of the week and you have excess capacity in your entertainment venues, it might be a perfect time to offer them a ticket to that entertainment venue. And same with off-time offers, same kind of deal. Clearly, there's a lot more data and a lot more offers. I just threw up some more metrics for you guys to consider. There are more even than this, but these are the main ones that I've found are used in casino loyalty programs. So not to belabor the point, but the idea is that if you took each one of these and dropped them into your buckets, then you'd sort of be able to say, oh, okay, how does this map to all the offers we have? Or maybe come up with new innovative types of offers that will get higher engagement from your players. So any questions at this point? Did all that make perfect sense and nobody has a question? Come on. No? All right. I want to bring you one more acronym just because acronyms are fun. DRIP. Discovery, Refinement, Insight, and Process. So discovery is, hey, what kinds of questions should we be asking about our engagement with our consumers or players in the case of casinos? And the refinement is really about taking those questions and making sure that we know how to ask the question. One of the hardest things in data science is asking the right question in the right way. Oftentimes, it's easy to apply an algorithm once you know what the question is. And then finally, insight is, okay, we asked a question, we got an answer. How do we interpret that? How do we make sure that we are actually taking the answer that we've got and understanding it well enough to apply it? And that comes to the last point, process. How can we best use that answer once we have it? Can we use it to make our communications more efficient? Can we make our communications and engagement pop? Can we get the consumers more excited? Can we make sure they never miss an opportunity? Can we support them better in customer support? There's all sorts of places where engagement with a consumer can facilitate either them buying, them buying more frequently, them getting better support, giving us feedback that we can use to build better products, all those sorts of things. Okay. We've seen in the last probably 6 months this tremendous increase in interest in large language models, especially generative large language models, ChatGPT, those sorts of things. So one of the things I wanted to put out to the community is, how can we take what I just went through, the sort of basic art side of things, and use that in LLMs? So one of the things that LLMs are doing is statistical categorization of contextual areas of interest, right? A lot of words there, but it just means they know where to look for the meat. Yeah, attention, right, exactly. Especially auto attention. So you can take an LLM that's been trained in the broad, and you can then auto-tune it in particular areas of interest. So if you look at all those kinds of data points that I was pointing, and you were to put that into an auto-training model along with your offers, maybe it could help you look at, find interesting sort of connections that you hadn't thought of before. Because it's always uncovering new information and how to use it. So you might also use that if you have an application that's engaging with your customers on your behalf. Right? Think about it, you can have a conversation with them. You don't want to do that in person because it's too expensive. It's very expensive, right? So if you can actually make that engagement, say chat or some other back and forth, smart about these metrics, then you can use that contextual sugar to improve that communication. And I guess I said that with the chat, so we'll go to the next. And then future studies, I consider this I've been in this game for a lot of years. I consider this an emerging technology. I consider it a technology in its infancy. I don't believe that we have seen where this can go yet. We have some ideas, and maybe there's people in the room that are trying to use LLM and predictive generation in some of their business engagements. Guys, you're on the frontier because it's going to be a wild ride over the next few years. So that's it for that presentation. Any questions before I bring Thomas up to talk about? Yes, go ahead.
Yeah, can you go back, I think 2 slides? Yeah, asking the right questions. So are there, is there a specific, anything where you say like how do we get to that right answer? Or knowing what the question is? If we're given data, how do we know, how to compare which sets of data and columns together? How do we get a sense of that? Are there
You can start with the pretty basic analysis, like principal component analysis and clustering, right, to see what's correlated with what. But really, I just sit down with your business expert and just understand what's going on. Like an example of how I got a huge amount of lift out of a financial model was modeling free cash flow. Like I had a bunch of financial metrics, right? And I noticed that the information value, which is using logistic regression to rank features based on value to the model, it was dropping revolving credit balance. And I said, BS, it's dropping revolving credit balance. That makes no sense. That's a huge indicator of default, right? Because we're trying to predict default. So then I said, okay, well, based on this person's income, how much are they likely to be paying for housing? Okay.
So disposable income.
Yeah, no. What I did is I built an entire cash flow model for the individual, and then I estimated their amount of cash on hand, right, after paying all their bills. And guess what? When it passed 0, people were likely to default.
By the way, there's a backstory to this. We were building a credit scoring application for a major bank. This particular feature was not in their existing app. Think about that. It's so obvious, right? How could they miss that? We're talking about a large bank. So sometimes, to answer your question, it's about, as Thomas said, making sure you understand what the business, line of business expert really is looking for. That doesn't mean they always know, though. As an example, there's a bunch of guys at the bank that never thought about that. Oftentimes, there's a technical answer to your question, and then there's a sort of social answer. The technical answer is there are tools that you can use to discover intrinsic relationships and importance of data in your data set, principal component analysis, clustering, and so on. Then there's a social side of it, which is to make sure that you have buy-in from your sort of team, your expanded team, all the people that are stakeholders in the process, so that you really listen to them and you make sure that it's all documented. And you can have, once you have a big long list of what everybody thinks is important, then you got another problem, which is sorting that into some kind of actionable order, which can actually be the harder problem. I don't know if that answered your question, but it was a good.
I've actually got two things to add.
Sure.
So one really important thing, spending a lot of time with your data. You can
Yeah.
apply any kind of algorithm or whatever, but unless you actually spend time graphing things out and really getting to know what are the strengths of the data, the weaknesses of the data, you know, things like signal to noise, all that kind of stuff, that's really important, just digging in, really getting to know your data. And the second thing, which is more of an emerging thing right now, the funny thing is ChatGPT, if you actually go with ChatGPT Plus, not that I use it all the time, but there are certain cases where you can just upload your data or upload your data, and it can be like, hey, ChatGPT, can you like analyze this? And it'll look at the structure of your data and it'll suggest like, oh, you know, a random forest algorithm, you know, using these features, and it'll just pop out some code. So, you know, for people who are new and maybe, you know, where you're just still in the process of like deciding what algorithm to use, that could be really useful for, you know, that kind of idea mind.
Okay.
Are you just popping it in as a text field, or does ChatGPT have
You
like?
just drop it into the text field.
Yeah, just data.
It does
You
a.
just upload data.
It
do you
has
do
some data formatting subroutines. It knows how to,
CSV.
because it's got lots of examples of how data is organized and presented
Well,
in
from the
data
GitHub
sets.
projects, yeah.
Yeah, well, not just GitHub, but yeah. And so what it does is it takes all that and uses it for the
And
generative stuff.
Specifically speaking about the plus feature where they
Yes.
actually have a code executor.
You can do that too, yeah.
Yeah.
Or if you're using Copilot or whatever.
Yeah. But specifically, you know, it lets you upload data. And it just
I understand
analysis
Kagel's
for you.
about to introduce something as well, which
Oh,
would be
yeah.
very cool, right?
Yeah.
Are you guys all familiar with Kaggle?
Yeah.
Yeah. So they're talking about adding, you know, generative LLP into their framework, which would help people take a piece of data and say, all right, suggest how I ought to go through.
Replit has their own LLM
Right.
too for forever.
Yep.
Yeah.
Another question?
Yeah, can you go back to the other slide? The second to the last. Are there, because you don't want to so, large language models, like, do you have any like specific examples where you apply, like where you took a large, a model that was traditionally used for something else, that you took a separate data set that like is not necessarily for that model and used it?
Well, models that are trained on one data set can often be useful in other data sets. That's sort of the whole point, because you want to train on a representative data set that is, you know, maybe specific to a given industry or area of interest. But then if that model, if those same kinds of data points are reflective in a different industry, you can move them all over and reuse it. They do it all the time. But the more you train a model on a particular vertical that you're interested in, the more likely you are to get a better model. Yeah. So, but yes, you can often take models and move it over and place them on top of other similar data. They do it all the time. Yes?
So on that note, are you guys using a pre-trained model, or did you guys design your own architecture to train onto your own data sets?
Done all the above over the years. I haven't done a lot of work with LLMs. I have some colleagues that are, but most of my work has been in symbolic regression, which is an entirely different field. Yeah, it's cool stuff. I'll give a talk on it and how we hack the stock market with it, stuff like that. Okay, so I should probably turn this over to TJ.
Do you have any of, this is a random aside, do you have any old data on how it performed during the stock market crash?
Yeah, my fund didn't crash. So.
No, I know exactly, but if you have some of that old data, that'd be a beautiful white paper and Prezzo. I'd love to see that. How Deep Green didn't eat.
Yeah, so you ready to plug
I'm ready.
in?
Yeah, let's plug it in.
Plug it in.
Yeah, the model they were using to run that hedge fund, Deep Green, actually continued to perform pretty reasonably during the chaos of 2008 and 9, which is more a testament to its efficacy
Actually,
than
it's
anything else.
2007, the quant.
Was it?
That happened, yeah. 8 and 9 were a different thing, but similar.
Really? Well, that's all I know.
Oh, yeah. Is it not working?
Let's not lock this over.
So what did I do wrong?
Okay, so one of the things I find is really challenging for a lot of people when they consider machine learning and autonomous drones is how the heck does a computer see? Like how does a machine orient itself in an environment? And I think a lot of people have trouble going from the first principles of like mathematics they understand to something that abstract as a machine, being able to path through an environment, being able to understand images. So I'm going to try to take you through a pretty simple process going from the basics to some of the modern techniques that are being applied today for drones. We've all seen the dog. I'm sure we're, having a bit of a Terminator moment with some of these technologies, but we can demystify at least some of them. So let's talk about convolutional neural networks. They're a pretty simple concept, and the idea is that we're going to use image features as nodes within a neural network. We've all seen neural networks. And let's say I asked you to tell me about this building. If I asked you to estimate the value of that building, you might do something like count the number of windows, right? But pretty quickly you'd say, I really don't have a good idea of how this might work. So if we were going to start plugging things into a neural network, we could do one for every pixel, but that'd quickly get out of control. So instead, we would prefer to break apart the image into different composites, right? And we can see a Sobel edge detector is a common one, right? So I'll just let the guy from Numberphile describe it because he does a better job than I ever could. Is it going to work?
Do you have your, are you tethered?
Oh, no, I don't actually. One sec. It also doesn't seem to autoplay from the embedded image.
You can just wing it. It's pretty easy to talk about that.
Well, actually, most of my presentation is is these parts. So basically what he shows is that those image decompositions, right, replace those features in the nodes. And what that allows is, and it's actually a kind of a two-way process, right? Because you start with a known image and you work backwards to the decompositions that are most predictive. And then from there, utilizing those decompositions and aggregates of decomposition. So you can think of layers of a node, right? You could have the first layer being the first order decompositions and the second layer being composites of decompositions. So if we go back to this image, this one, right? You could imagine an edge combined with some color might dictate something. Like if you're looking at a stop sign, maybe red and then the edge of the S are very predictive, right? For like, let's say an algorithm that's trying to find stop signs or drop phones. So then he carries on and speaks about how there's basically a moving window that slowly internalizes these images, produces the outputs, and then how that process percolates through the various layers of the neural network. So pretty interestingly, right, this is how we get image recognition at a more, the technologies stack, right? Very rarely technologies just spring up. It's often technologies perform in aggregate. So much of the modern, very quick image recognition technologies like YOLO, you only look once, and it's SSN or SNN, are basically just revisions of regional CNN. And if I don't have maybe I can just bring up my notes 1 second since we don't have the video. I think it's this one.
I'm not showing anything on the screen.
I can't help you with that.
Yeah, it's the, you have to exit out of the president to get to
Will it just mirror my screen?
There you go.
Is it not drone 2? Should be drone 2. Did I not save it? Oh, here it is. There we go. So then, which one was it? Oh, do I not have the image for it? Oh, that's too bad. Oh, well.
Probably Google it. There's some pretty good breakdowns.
The problem is it's not going to.
Yeah. Oh, yeah.
Yeah. So basically, there is RCNN, which is regional CNN. There's fast RCNN, and then there's faster RCNN. And the advantages between the two, it sounds kind of obvious from first principles, but it's when the data cleaning effectively is employed, right? So that edge detection process, that image decomposition process, you'll have regional propositions where you're saying like, hey, we're going to try this area, see if there's anything useful here. Hey, we're going to try this area, is there anything useful here, right? And if you apply those proposed regions, if you select them prior to that image cleaning process, it's really slow, right? So then they move to we'll do our data cleaning, right? And then we'll propose regions much faster. And then they move to a different version, which actually has like anchor points, and it basically it allows the algorithm to flexibly propose regions around those anchor points, which are randomly selected, which can really improve clustering. Because if you can imagine, I'm trying to put a brick on a wall, and I'm just saying, I want to find a brick, and I'm using a region, and I just accidentally put it like right here, right? The algorithm has no visibility on the brick, but if I'm allowing an anchor point, and I'm like, where's a brick, it's much easier to find the brick on clustering. So that's why the anchors were much more effective for the faster CNN. This presentation was actually pretty interesting. So what he does, I think I do have this in my notes. I think I have a better, higher res version of it. There we can just zoom in on this guy. So we want to talk about how these technologies are extrapolated.
Trying to find a path between rooms.
Yeah, well, it's more about like we're talking about how is random and guess and check strategies employed to really allow machines to see, right? Because we don't think about our process as a guess and check process, but it kind of is, right? So for discovering meaningful pathways in a 2D space, you apply a similar idea, like I said, to the anchoring, right? You find the nearest obstacle, right? And you just continue to find the nearest obstacle from a randomly placed node. And eventually, you get a very nice distribution, and you can define a path through that distribution. Similarly, this can be employed in 3D spaces, right? And these are called probabilistic roadmaps. These are developed in the 90s. This is not by any means new technology. And this is how we've been using this to automate machines through pathways for quite a long time. Very similar. Actually, this wasn't in the presentation, but since we've got the notes here, there's a lot of interesting stuff around potential fields, which is a way of modeling this with, pretty basic calculus, but with, fields, repulsors, attractors, stuff like that. This has some problems compared to later approaches, which we'll get into. Mostly problems with local minima, which is always a problem in data science. So, this kind of brings us around. Shame that we can't watch the video because the guy does an excellent job of describing how these technologies come together in aggregate, right? So all of those technologies are kind of disparate things that have happened along the way. But eventually what happened was we got really, really, really good radar, and we got really, really good cameras, and we had a ton of ability to manage those streams in real time, which was not something we were able to do before. And we were able to use sensor convolution to look at that information all at the same time. Out of that popped SLAM, right? And SLAM is simultaneous location and mapping, right, I believe. And it's kind of the holy grail of autonomous drone problems. It's saying, I don't know where I am, and I want to know how I'm going to get somewhere, right? So you're trying to do both at the same time. And that can be really challenging because you're working with two conflicting problem spaces at the same time. And the key way that we beat that problem is with loop closure, right? Because what happens is as the machine uses sensor convolution to move through an environment, it's saying like, my IMU knows I should be I'm accelerated about this much, I have a vague idea of the distance that I moved. My cameras are telling me from this edge that I've moved about this much. But when you close a loop and you return to your initial position based on all of that telemetry, you can basically warp your map and correct it for any errors that you've accumulated throughout that process. And what that allows you to do is provide much more stable maps of an environment. So for example, if you bought a dog and you were calibrating a Boston Dynamics dog, it's going to ask you to walk it around the space because that's one of the ways that it builds those localized maps. So I wish I had his diagram. Do we have a whiteboard? No, we don't.
Yeah, we do have one in the back. But
Oh, it's at the back.
I'll bring it up.
Yeah, I just want to do his, I thought his description of how the positions in space and landmarks worked was really quite, so I was going to show his, I suggest you all watch this video, by the way. It's quite good. Number file in general and computer file in general are, you don't have anything?
I have it.
So I'll just very quickly.
TCU.
Yeah, so very quickly, right? If we consider a position in space, these are all positions in space, blah, 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 and we keep walking more, and this is the final position, right? And this is a landmark, and this is a landmark, right? We know from our accelerometers and our cameras, we estimate a distance, right? But we also can use a landmark, right? And that landmark has relationships with every other position, right? You see what I'm saying? So given these relationships to the landmarks, right, we have a very accurate understanding. This is a pretty simple, yeah, it's a pretty simple optimization problem. But we're going, and then we get to xn, the final position, and we know these to be the same, right? We can start to reduce the error in that model. So if we had a loop, right, around a space, it might look like this. And what we would do is we could shrink it so that it actually was dead on. You can imagine how that might work. And then also the very interesting thing about this is it gives us a lot of information on the type of error we were experiencing from our sensors. And that error can be managed in real time. Yeah. It actually it improves the whole model throughout. So there you go, that's SLAM. You also hear things like VSLAM, which is visual SLAM, LiDAR SLAM. Okay, and with that, although I am absolutely no robotics expert, wish we had Brandon here, I'll take any questions if you have any.
So SLAM is a type of CNN, or is it two different?
No, CNN is older technology that is two-step and is not real-time, that is used to process images. It was one of the first image processing tools. From there, regional SLAM is the RSLAM. Yeah, or sorry, excuse me, RCNN was then utilized for image processing. Later, fast CNN, RCNN, and then faster CNN. All of those are still two-step, right? For current modern image processing, we're using YOLO or SSN or SNN, but image processing of those types is somewhat used. I mean, often we're using much more complex image decompositions, like differentials between images. Like if you look at Tesla's algorithm, which is almost entirely cameras, they don't really use LiDAR. They're pretty much, as far as I know. Do you know if they're using LiDAR? I don't think they are.
No, they're specifically anti-LiDAR. The
Yeah.
reason is because Elon believes that it's the cheapest sensor for the highest bandwidth of information compared to LiDAR.
That was my understanding. I just didn't want to say the wrong thing.
You're right.
So then they're using diffs, to try to predict what's happening between camera images. So while there are proposal regions similar to RCNN, it's not the same technology. There's a lot of stuff going on underneath. If you're looking for more things that are closer to SLAM, I'd look to like probabilistic roadmaps, which are more classic robotics. You'll look at particle fields, and very similar to this diagram. This is really probably the most accurate. This is this except populated by LiDAR is typically what you'll see in actual, production code.
So would SLAM kind of be analogous to like what dead reckoning is, except on the computer?
Yeah, actually, yes. Yeah, it's not hard.
Yeah.
Yeah, where you're using like specific instruments, like the distance to the angle of a star in the sky, that kind of stuff. Yeah, that's exactly right.
Thank you.
Yeah, so I'm no robotics expert either, but I know a lot of psychology, and this is really interesting because that's basically like embodied predictive processing models. Is pretty much how they think we see and navigate through the world. So
Yeah, it's very.
It goes back to the question: can you reuse the model in a different area?
yeah.
Well, I think fundamentally a lot of people overly mystify the human mind. I think a lot of that's nonsense. I mean, ultimately, it's just a chemical computer, and I think a lot of the time you'll see that it's not that we're I hear a lot of people say like, oh, we're reverse engineering the brain. And I'm like, nah, really. It's more emergent. It's like there is a pattern that yields the correct result and you can find it. It's like mathematics being co-developed and like co-evolving in different societies. It's not that like they invented mathematics. It's more that it's an emergent pattern and they just discovered it. Similar to like a good example of emergent patterns is like behavior of insects, right? Where they show group intelligence out of, you know, effectively drones.
We should probably let Peter have it.
Okay.
Take one more question and then Peter.
Who wants to be the last question?
Have you used ultra wideband, or have you used ultra wideband as far as like localized mapping?
I have used nothing. I have never even built a Richter set. So.
I challenged him to research this subject. Hey, you did okay.
Well, it's kind of
What?
for localized mapping to find objects nearby.
Yeah, that would be.
It's very cheap.
Yeah.
Yeah.
Okay, so Peter, did you want to? Do you need a presentation? Just gonna stand up and wave your arms.
Well, I could do that way, and I'll just put one slide up anyway.
Sure.
Do you want
Is there
the
a lapel mic?
Yes, it's right.
Set up? No?
the dongle?
That's compatible with the Mac there. I have a USB-C input.
Yeah, it works with the Mac. I was using one earlier.
If you don't mind, just.
You've been tagged.
Great. Am I good now? In that sense, I'm wondering, I've got a USB-C. Okay, I'll do something and it'll be planned out. But before that, just from the audience here, just maybe by show of hands, who here spends like 10 hours a day, 4 or 5 days a week doing software engineering and building and writing? Okay. So I'm going to ask a few people, what is AI? It's got to be one sentence answer, but really anybody, and in particular those people that don't do engineering as a career. What is AI? Dot? Please. We're in an AI meetup. I'm just wondering to anybody, a definition.
Smarter than most humans.
Smarter than most humans, a good answer. AI is smarter than most humans. Say that again, please.
I agree with her, more than human.
Okay. Anyone else want to take a crack, please?
Computer generalization of the real world.
Computer generalization of the real world. Any more in the back there? Yeah.
A series of completed steps.
Series of completed steps. Okay. I'm going to use a definition that's my own as I discuss it, and I believe in the truth of it. We've all got different definitions for it. So no sweat if we don't agree immediately on definitions. I think we generally should have some common starting point. And I'm doing what I can with the USB-C to no avail. I'm not sure.
It worked for mine.
I plug it in, and then,
Make sure it didn't get loose. That's what it was.
oh, hey, AI is computer cords being plugged in. Okay. I said I put up one slide. This is one. This is just a homepage to the website I put up last night. It's called the 702 AI. Tagline there, own your AI or AI will own you. Am I on and good and we're here? Yeah? Okay, hi. I'm Peter Smith. It's sort of odd how I got here today. I got off a plane yesterday. I thought I'd be away and I'm glad to be here. Decades ago, generations ago, my grandpa was a farmer, farmed tobacco in North Carolina. After that, my dad ran record stores on Long Island in New York. And me today, I do entrepreneurship by way of pressing buttons on a computer in front of a screen, and it pays the bills. What I do it for is probably related to what my grandmother did, who was a lobbyist for nurses' rights. She was somebody who in New York got it passed so they had a professional designation. It gave them pensions and all of the things that anyone might expect if you're doing a professional job that you would receive in the long run of a career. It's the social part of that that really matters. It's the, well, we can fix your body up, it's nice and all, but well, what is it doing for society? And so when I do the engineering that I do, it's usually through that I'm looking at a project selection. Not a one presentation in the beginning today out there in the forum on the patio left out AI. every single one of them, everybody on the planet today is doing something with AI. How is that possible? So to me, the definition of AI is it's the latest software. There's something called optical character recognition, OCR. It's been built and good for a while. It's how mail gets read by computers. It's the ability to look at an image, understand what the letters are. For a while, that was called AI, and not a single person today calls it that. Now what we call today AI is either large language models that have just come out of ChatGPT and all the things that are like it, or neural networks like we're just talked about. These things are called AI, but in the years to come, something else is going to be called AI, and we might just call large language models, and it'll be relegated to mere technical, mechanical workings. And if it's that definition that you work from, you have to look at how it's applied and who it's coming from. It all matters, and not the least of which, how do you feel about it? Are you afraid of it? Are you terrified? Are you excited? Are you looking at the possibilities to improve your productivity and your creativity? And I am ever creative and seeking more ways to be creative. So I, for one, in my day-to-day, embrace it in a social way, not necessarily just the pressing the buttons on the computer, which is, it's a necessity. I don't think there's any lack of opportunity with it, especially if you're an engineer. But if you're not, then I think it's worth knowing what goes on behind the screens and how it is that tiny little teams can appear to be doing great things using AI. It's AI, it's software. You could swap out either word and be talking about the same thing. So, we've all got something that we came in here for and wanted to learn about and wanted to discuss. And right before this, I was taken aback. One gentleman standing in the back there asked me about something called LangChain. And I wasn't going to speak too much about anything particularly technical. A LangChain is something that engineers use in order to process large language models without having a user interface and do it effectively. And I said, basically, engineers hate it because there's an abstraction that it's providing that might not be right. That might be more work to implement LangChain than to just do what LangChain itself is doing on your own. So does that really make your job easier is an open question. On the other hand, they're funded by Silicon Valley. They've got millions and millions and millions and millions and millions of dollars to figure it out. So maybe a year from now, it'll be really, really great. Maybe a year from now, it'll be dead. And it won't matter to Silicon Valley, but it might matter to you all to know this type of thing exists. So things like LangChain or the end result. I'm just going to stick with the end result. I've got a few projects that I've worked on over the years, and without going into the beyond the headline for any of them, all of these, if you clicked on them, would give you a short synopsis. Yet, with the most recent topic being visual, we just talked about how can a computer read an image. About half of these projects, maybe all of them in one way or another, are about viewing images. The one called Flexin is about how can people in this city that may also exist around the world learn to do what Cirque du Soleil performers do. How do you do a handstand? How do you go beyond a handstand to a one-arm handstand? How do you do things that are so seemingly impossible without a coach? Well, I tried to learn that, and I learned from a fella who posted a YouTube video that got wildly popular. I didn't know it at the time. He was the world-renowned breakdancer Simon Atta. We became friends because he's incredibly technical, and he guided me on, well, what is a technically good handstand? And we realized together, you could use AI to figure it out. And when I say you, I mean I, and when I mean I mean a team of 3 or 4 of us. We're not a whole massive corporation, but at the end of the day, if you wanted to learn how to do a handstand from a jungle in Africa, all you need is a phone, point it at yourself, have your body in the frame. It will be able to show you, superimposed on your video, the line of your body, and it's very important to be straight. So if the computer can understand if you're straight, and you can understand being straight is important to a handstand, you can work with the tool where you might otherwise be looking to a coach and being in a major city and having to have all the resources of humanity around you, and in particular, a very rare skill, one-arm handstand. How many people on the planet can do it? So there's a great democratization of skill that AI is able to provide. To be able to do any absurd little creative pursuit is so much more possible, especially in the physical world, when you can learn it without necessarily having to be around people that already know how to do it. Before large language models and neural nets, most of what AI was called was expert systems. Expert systems would be trained based on a doctor, would give answers to thousands of questions. Engineers would take those thousands of answers and build what they would call AI. And it would be very brittle. It would basically be a few people's opinions, but it couldn't do anything outside of that domain. And why people are excited about these is because of domain transferability. How easily these things can be used in one domain that it wasn't anticipated in is pretty remarkable. I'll take one more, which has just come into my world recently, was called SOM. Let's take SOM. SOM, short for sommelier, and I gave it that because I can't spell sommelier. If you drink wine, you might want to know from a wine list which ones on the list are good for you to drink. This is a problem that's been, problem's a strong word for trying to pick out a wine, but it's a technical challenge to implement, and it was tried in 2014 and 2016 and by large companies, and they put a bunch of money into it and failed. They're not around today. And when in the last couple of weeks, a fellow that's got a great wine business asked me, was it possible? I just started to ask some others in the general world of image recognition and then text classification. He sort of agreed that in 2014 and 2016, it was a fool's errand, but today, the technology's gotten much better. So we're in 2023, we're talking about a decade's difference, and what was previously impossible, no matter how much money you threw at it, is pretty possible. I completed a technical demonstration in about 2 days by a very small team, and for a very small amount of money. So when you get into these things about AI, I really believe that what we're getting excited about is the ability for people, small teams across the world, to do things that would have otherwise taken $1 gazillion to do. That is, I believe, how the Wizard of Oz effect happens. You had a few people behind a curtain projecting this much bigger, harder thing. And that's really amazing, isn't it? So I can go on, and I often do, and I'm going to flip it back to anybody here to just open up the idea of one. At the 2:45 p.m., I'm doing more of jibber jabber about this. What happened was sort of unclear to me behind the scenes. I'd intended to do more of a structured thing. For a roundtable discussion, 2:45 p.m., it'll be in the theater to talk more about AI, ask questions, and get involved with it.
Rich, I wanted you to make sure you told everybody he's going to do all this in more detail, especially oriented toward programming and programmers.
Well, sure. It'll go towards whatever the audience wants. If we get programmers in, I'm happy to talk about LangChain or how do you work with matrix multiplication and whatever level I can discuss it with. I'm not shy about talking, and it's certainly nice for my ego that you all are listening, but I really do like having a back and forth. So sure, right in the back, we've got a question, and we can keep them coming after that.
That talk will be today.
2:45 p.m.
2:35 p.m.
2:45, sure. Hey.
An almost identical idea for an app that would be very successful would be an app to assist in welding. Because welding, I found, is a hilariously difficult skill, and the people who are best at it are terrible at explaining.
Yeah. So there's this problem. We're talking about welding for a moment. People that are really good at the thing can't talk about how they do it. It's a very rare individual that can both be great at the act as well as the explanation. And there is certain popularity that folks get in YouTube. When you can both be great at the skill and be great at articulating it, you've got 1 million followers on your welding channel. You are the world's welder at that point. Now, for the rest of the people that are just good at it and happy to be good at it very quietly, I think that they, in a more maybe artistic way, get what they're looking for. It's not fame, it's just they want the weld to exist. And I believe that's probably the majority of the audiences of the people that are looking into how do you do welding. And it's always good to have some type of entertainment and human to look with and interact in the eyes of each of us. We want to see each other. But having an assistant that is digital in your pocket, available at any time. It's as great a way to learn chess as it is in the next year, whoever makes the welding app to learn welding. So next question or thought or comment? Please, what do you got?
I'm just curious about the wine app. So is it like something that recognizes wines, or is it like a recommender system, or what is it?
Sure. So the question is about a SOM, and who thought of it is recognized in the UK as the #1 wine advisor. And he became successful by buying and selling wine, buying it off the vineyard, holding on to it for a decade, and then selling it back. And then his customers give him money to do that for them. He takes a percentage fee. And the folks in that world, they really love the money side of wine, the making it. But they're not so intelligent necessarily about the drinking it and the tasting of it and all of that. So he asked if it would be possible for those people that just like being around wine to get recommendations. He wanted an AI sommelier. When it was given to me, Michael Doerr said, AI sommelier. And I thought, well, we'll chuck together a large language model prompt that will then let the folks have a chatbot. And he said, no, not that. I want to be able to take a picture of the wine list at the restaurant and then make a recommendation. And in my head, it's that question of what is AI? I'm going back to text recognition and classification and getting into extracting that information useful about the wine from that list, which is price and year and its name, combining that with these people who are a part of this organization, have bought and sold wine in the past, some of that data, and then using some fairly off-the-shelf recommendation algorithms, not so dissimilar from Amazon's. People like you also bought, or based on your purchase history, you might like. That sort of recommendation, that's probably where this one would end in its first iteration. When it's done, it'll stop there and then go further along the way.
Would you sort of say, I like this wine, and keep track of that, and then do similarity recommendations?
The question's about the personalization in the app. Can you heart a wine and then see more of that in the future? There's no reason not to. I don't always like the idea of personalization at that level, because I think when my own personal experience of Netflix comes up, it's always the ones that surprise me that I actually like, and the ones that are 97% likely to be liked by me that I've already seen. Obviously, I've watched it. Of course it's 97% match. I've watched it 13 times. It's really, 99%. But it's the one that's like 67% likely to be liked by me, and I turn it on because somebody in real life said you might like it, that I either like it or don't, but I love to argue about it afterwards, whether it was good or not. So I get touchy in a personal way about hearting things and personalization. That said, it's a commercial endeavor, and you give the people what they want at the end of the day. Should they like the idea of getting recommendations and want them to be more for them? The reality is, with a very small team, it's very possible to achieve that effect today because it's all built on the shoulders of giants. Most of what OpenAI has done is being replicated across the world by small teams, engineers in basements that are nameless and faceless, doing great work based on the idea of math. We can all do math, we've all got the same brain, so when somebody's seen it and then said that they've seen it, other people can say, oh, okay, yeah, I could probably figure that out on my own. So it's cool in that way. AI is very accessible if you've got a penchant for sitting at a computer still for 10 hours.
Okay, so maybe one more question.
Oh, please, yeah.
One more question. Anybody?
Hi.
Hi, just curious if you probably have worked with product designers. Just want to hear your general experience working with them and any like technical requirements that you need, when they're delivering assets to you.
Okay, so product designer. If you just clarify, when you say product designer, do you mean in the visual graphic sense, or do you mean in the holistic idea of we've got to have something that can earn money and all the things that go into that?
I guess we'll lean more to the visual interaction.
I'm going to click into something here. It's videos. I think the headline is that I like to talk a lot. I do. A couple years ago, I answered this question with a collaborator of mine. Web design is design in the web. The reality that I most like to inhabit is a designer that can actually implement the design. It's very difficult to get from a designer static mock-up of an app and then You know, I could ask for like higher resolution, hey, could I get some SVGs? But it's often much harder to ask for, could you give me a user interface that I can actually build? Because sometimes you get into the data structure and what's being asked for is incompatible with how the data is shaped. But when you've got a designer who's capable of implementing, in a lot of cases, a reusable component for the web or a mobile app, what you get into then is a knowledge of the constraints. Now, that's ideal. Sometimes it is the case of, give me your SVGs and I'll do my best. And a lot of times I don't ask for too much technical stuff. I've done it long enough to understand it's got to be my flavor of development that's able to make the technical side work. It's what I'm hired to do, and what my team is usually very capable of doing is abstracting from the idea that it has to look this way, the technical requirements, and often we're able to come up with workable prototype that the designer then critique and so on. So thank you very much, everybody. Thank you, Tim. Thank you to all those that asked questions. Thanks for all those who patiently sat through and smiled and looked entertained. And I'm here for the remainder of the afternoon and looking forward to talking with everybody afterwards. Thank you.